Hi, it's Mrs. Seitz, and to kind of pick up where you guys left off on your factoring lesson is some application problems that we're going to see in geometry. So if you take a look at this application problem, it says a city builds a rectangular sandbox in the corner of a square playground. The area of the sandbox is 6 square yards, and that's important. What is the area of the playground? Well, if you look at some of the dimensions that are given to you, one is that they tell you it's X yards for the length, X yards for the width. And then if you look very carefully, you can see that on the other side that the 12 only goes up partially and that the 13 only goes over partially for the width. That the sandbox itself is 6 square yards, okay? So you could start maybe figuring out, okay, 1 times 6 will give me 6, 2 times 3 would give me 6, 3 times 2 would give me 6, and start playing around with the number combinations to try and figure out what x would possibly be. But to kind of build upon and expand upon what we were learning on with factoring and how this kind of ties in, I actually created two expressions to represent the length and the width of the sandbox. So let's take a look at the blue one first, x minus 13. I know that the whole entire width is x. But if I take off the 13 yards, so x minus 13, it's going to give me the leftover width of the sandbox. So far, let's write down x minus 13 in parentheses. Same deal with the length. I know the whole entire length of the sandbox is X yards. If I take off the 12 yards, I'm going to have the leftover dimension for the length of the sandbox. So I'm going to write for the other dimension X minus 12. And I know from area that length times width is going to give me the area that I need for the sandbox since I have a square. So I'm going to set this equal to 6. Okay, so you guys learned previously that in order for you to start figuring out what this is, we actually need to FOIL this out, set this equal to 0, and then start solving this. Okay, so let's FOIL this out. So your firsts, your outsides, your insides, and your last, and that would be equal to 6. Your next move is you want to subtract the 6 because you want to set this equal to 0, and you want to combine any like terms that you might have. So I'm going to circle those like terms. So we'd have x squared minus 25x, and then 156 minus 6 would give you plus 150, and that would be set equal to 0. So again, before we can start even solving this thing, we have to make sure that it is FOILed and then set equal to 0. Now we're going to start factoring this one more time to see what we can figure out what our answer for x is going to be. So I'm going to break this apart. I'm going to split apart the x's. I know that this is going to be two of the same sign because I see a plus sign at the end and I see a minus sign with the b term. So I need to think of a combination of numbers that when I multiply it together, it's going to give me 150, but when I add them together, it's going to give me negative 25. So I can start listing combinations, but the combination that would work is going to be 10 with 15. Because if I multiply negative 10 times negative 15, I'm going to get positive 150. But if I add those two numbers together, I'm going to get negative 25. Okay, you also learned in that video that the next step is you need to set each one of these quantities equal to 0 to start solving. Okay, so if I added 10 to both sides here, I would get an x answer of 10. And then over here, I would get an x answer of 15. So sometimes whenever you solve these problems, you might get an answer that would be possibly what they called an extraneous root, which means that an answer that might not be correct based on the context of your problem. So here's what I mean. Let's take a look at the answer of x equals 10. If I would substitute in x equals 10 into one of these expressions because ultimately I want to find the area of the playground. If I plug in 10 in for x, 10 minus 13 gives me a negative answer of -3. Same deal if I plug it in here. I would get 10 minus 12, which will give me -2. I can't have negative side lengths, so this would be an extraneous root. Which means that x equals 10, even though it popped up as an answer, it doesn't make sense in the context of this problem. So we would not want to include x equals 10 as an answer choice. If we tried x equals 15, look what happens instead. If you plug 15 in for x, 15 minus 13, that gives you a positive length, and 15 minus 12 also gives you a positive length. So that means this would be the answer choice that would work. So we would get lengths of 2 and 3. So then we would go back up here and we would want to start figuring out then what the actual dimensions would be then of the whole entire playground. Okay? Remember, this was just confirming that the area of the sandbox was giving us would be our area would be 6 square yards. And that does in fact work out because 2 times 3 would give us 6. Okay? So again, this was just figuring out that the area of the the sandbox was 6 square yards. We need to now figure out what the whole entire thing is. So if I know, if I plugged in x here, x minus 13 would give me 2. I'm going to put a 2 right here. And if I put a 3 in here, I now know the total dimensions, length of width of the entire playground. So I know this is a 15 yard by 15 yard playground because 13 plus 2 gives me 15 and 3 plus 12 gives me 15. So to answer the final question, what's the area of the playground? It's 15 yards by 15 yards, which will give me 225 yards squared. Okay, we're going to try another one just to make sure we're good with this. Okay, in this particular problem, you can see that we are given the dimensions and we're given the area. So the dimensions, though, this time are set up as algebraic expressions. So we have a length and width of x minus 5 and x minus 12 feet, and we know the area is 44 square feet. So again, what we want to do, we know area of a rectangle is length times width, so we're going to do x minus 12 times x minus 5, and we know the area is 44. So again, length times width equals area. So that's where that's coming from. Okay, in order for you to start solving for x, you need to FOIL this out. So x squared, so negative 5x. The inners would be negative 12x, and the last would be positive 60. That's still equal to 44. We need to now set that equal to 0. So we're going to subtract 44 to both sides. I'm also going to combine my like terms right here of the negative 5x and the negative 12x. Okay, so now the next move is we need to factor this out and set this equal to 0 and solve. So I'm going to split my x's. I know that I need to have the same sign in here based on what I have here at the end, and the sign has to be negative in both. Okay, I need to think of factors of 16 that whenever they multiply together, they get you positive 16, but when they add together, will get you negative 17. So that combination is going to be negative 1 times negative 16 will get you positive 16, but when I add them together, will get you negative 17. If I set those equal to 0, I'm going to get x equals 1 as a choice and x equals 16 as a choice. And again, you want to double check to see if there's an answer that doesn't make sense when you plug this in. So let's start off with the x minus 1. If I plug in x minus 1 into this expression, or x equals 1 into this expression, 1 minus 5 is giving me a dimension of negative 4. you can't have a dimension that is negative. So therefore, this is an extraneous root. So x equals 1 would not be an answer choice that we would want to keep. Let's try 16. 16 minus 5, hey, that's 11. So 11, and then 16 minus 12, that's going to be 4. So whenever you work that out, we have dimensions now of 11 and 4. So those would be our answers because I know 11 times 4 would give me 44. So we're going to say the dimensions are 11 feet by 4 feet. Okay, and again, the whole purpose of understanding this factoring and solving these equations by factoring is to be able to now apply these to some geometry problems.